Day 418 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2040, kth smallest product of two sorted arrays. The difficulty level is hard, but don't worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given two sorted zero-index integer arrays nums1 and nums2 as well as an integer k, return the kth one-base smallest product of nums1 of I times nums2 of j, where 0 is less than or equal to I and I is less than nums1 dot length, and 0 is less than or equal to j, and j is less than nums2 dot length. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples anyway, just to make sure that we're doing this problem correctly. So in example 1, we have the input nums equals an array of integers 2 and 5. Then we also have in the input an array of integers nums2, which equals an array of integers 3 and 4, and we have k, which equals 2. Our output is 8. The explanation says the two smallest products are nums1 of 0 times nums2 of 0, which will be 2 times 3, which equals 6. Then we have nums1 of 0 times nums2 of 1, which will be 2 times 4, which equals 8. The second smallest product is 8. So let's go ahead and break this down one step further. What we want to do is find the smallest products, or the kth smallest product that we can find by multiplying integers in this array by integers in this array, right? So the first smallest product that we can create is we could just do 2 times 3. As you can see, these are the two smallest numbers in each array, so that will, when we multiply them by each other, that'll give us the first smallest product. But however, in this case, we want the second smallest product because k equals 2. So now we're going to take 2, which is nums of 0 right here, nums index 0, which is 2. We're going to multiply that by, this time we're going to multiply it by 4 because there's only two numbers that we can choose, 3 or 4, and that's going to give us 8. So since 8 is the second smallest product, because k equals 2, we return 8. Now, as you can see, if we did 5 times 3, that gives us 15. That's not the smallest product. And 5 times 4 is 20, which is not the smallest product. Both of those products are greater than 6 and 8. So those would be, that's just an example of how we want the smallest product, not the greatest product. So the smallest products would be 2 times 3. That's the absolute smallest product. And then the second smallest would be 2 times 4. So just in case that didn't make sense, y'all, let's take a look at example 2. Same principles apply. This time we have a little bit more numbers to work with in nums1. So let's go through it. So in example 2, the input nums1 equals an array of integers -4, -2, 0, and 3. Nums2 equals an array of integers 2 and 4. This time k equals 6. The output is 0. So since k equals 6, we want to find the sixth smallest product we can create by multiplying elements in this array by elements in this array. So the explanation says the six smallest products are, we're going to take index 0, nums1 index 0 times nums2 index 1, which will be -4 times 4, which will get us -16. So as you can see, if you multiply, first we all need to know, if you multiply a negative by a positive, that's going to get you a negative. So if we multiply -4 times 4, that's going to get us -16. Then we do the same thing, or we could do -4 times 2, which will get us -8. Boom. Then those are only the first two smallest products. Remember, we want the six smallest products. So then we keep going. We do -2 times 4, that's going to get us -8 again. And then we could do -2 times 2, that's going to get us -4. So now we have the fourth smallest products, right? Then we keep going. We do 0 times 2, that's going to get us 0. Then we could do 0 times 4 as well, and that's going to give us another 0, but that is the sixth smallest product that we can create, 0, so that's how our output became 0. So let's go ahead through this one last example. Since it's here, we might as well go through it just to make sure we're really making this make sense. So in example 3, we have the input nums 1 equals an array of integers -2, -1, 0, 1, and 2. Nums 2 equals an array of integers -3, -1, 2, 4, and 5. K equals 3. The output is -6. Explanation says the three smallest products are, first we do -2 times 5. That's going to get us -10, which will be the first smallest product. Then we do -2 times 4. That's going to get us -8, which is the second smallest product. And then finally, we could just do 2 times -3, which is, this 2 right here times -3, which is going to get us -6, which is the third smallest product. And that's what we're looking for because K equals 3, so our output will be -6. So with all that being said, y'all, now that we understand the question, let's get into the fun part, the actual solution, y'all. The solution is not that difficult. It's a little lengthy bit of code, but we'll be able, it's nothing we can't handle. So let's get into it. Now, the first thing we need to do is we're going to create our helper function. This is going to be a binary search helper function to count how many, products are less than or equal to val for a negative number. So for that, we are going to just come right here outside of this main function, and we're going to say func. We can call it get value 1. Then we're going to open up the parentheses, say _x colon. That's going to be an integer. Then we're going to say comma underscore nums2 colon. That's going to be in out. Then that's going to be an array of integers. Come outside of that array of integers. We're going to say comma. This time we're going to say _m colon. That's going to be an integer. Then we're going to say comma. Then we're going to say _val colon. That's going to be an integer as well. And this whole function is going to return an integer. Boom. Then we're going to open up the brackets. Now we're going to create our pointer. So we're going to say var left. We're going to set that equal to 0. We're going to say var right. We're going to set that equal to m minus 1. Then we're going to declare another variable called result. Result. And we could just set that equal to m. Now we're going to do binary search from left to right. So we're going to say while left is less than or equal to right. We're going to open up the brackets. We're going to say we need to find mid for our binary search. So we're going to say let mid equal left plus, open up the parentheses, right minus left. And we do it like this to prevent overflow. And we're going to divide that by 2. Then we're going to say if x times nums2 square bracket mid is less than or equal to val, we're going to open up the brackets. That means we found a valid index, so we're going to say result equals mid. Boom. Then we're going to try to find a smaller index, so we're going to say right equals mid minus 1. Come underneath that, we could say else. Open up the brackets, left equals mid plus 1. And then finally, we need to count all of the valid products. So we could come right here. Well, sorry, y'all, outside of the while loop, come right here. And we can say return m minus result. Boom. Now we're not done yet because now we need to create a binary search helper function to count how many products are less than or equal to val for the positive or non-negative numbers. So for that, we are going to come underneath this helper function. We're going to create another helper function. We call it func. We call it get value 2. This time we're going to open up the parentheses. Let's say _x colon. That's going to be an integer. Then we'll say comma _nums2 colon. Once again, that's going to be in out, and that's going to be an array of integers. Then come over outside of that array, we're going to say comma underscore m colon, that's going to be an integer. Then we're going to say comma underscore val colon, that's going to be an integer as well. And we are going to return an integer. Boom, just like that. We're going to open up the brackets. Same thing, we're going to create our pointers for our binary search. So we're going to say var left, set that equal to 0. And then we say var right. We're going to set that equal to m minus 1. Then we're going to declare another variable called result. Sorry, y'all, it should be result. And we're going to set that equal to 0. Boom. Now we need to start our binary search. So we're going to say while left is less than or equal to right. We're going to open up the brackets. We're going to say let mid equal left plus, open up the parentheses, right minus left. Come outside of the parentheses, divide that by 2. And we are going to say if x times nums2 square bracket mid is less than or equal to val. We're going to open up the brackets. We're going to do the same thing. We're going to count this index and all before it. So we're going to say result equals mid plus 1. Then we're going to say left equals mid plus 1 as well. So we can move to the right. So left equals mid plus 1. Then we could come right here and we could say else. Open up the brackets. We could say else right equals mid minus 1. Then we just need to return the total number of products that are less than or equal to val. So we come right here and say return result. Boom. Now we're not done yet. We have one more helper function, then we'll get into the main function. So for this is going to check if there are at least k products less than or equal to mid. So for that, we could just say func. We could call this one valid. Open up the parentheses. We're going to say underscore nums1 colon, that's going to be in out, and it's going to be an array of integers. Come outside of that, comma. Then we're going to say underscore nums2 colon, that's going to be in out as well. That's going to be an array of integers. Come outside of that, we're going to say underscore n colon, that's going to be an integer. Integer, comma. Then we're going to say underscore m colon, that's going to be an integer as well. Then we're going to say underscore mid colon, that's going to be an integer. Then we're going to say underscore k colon, and that's going to be an integer as well. And this time, this is going to return a Boolean. Then we're going to open up the brackets and let's get started. First, we're going to declare a variable called result and set that equal to 0. Then we're going to say for index n 0 ... less than sign n. We're going to open up the brackets, and depending on the sign of nums1 index, we're going to use the appropriate counting function. So if it's a negative, we're going to use get value 1. If it's a positive, we're going to use get value 2. So we're going to say if nums1 square bracket index is less than 0, then we're going to open up the brackets. We're going to say result plus equals get value 1. Open up the parentheses. We're going to say nums1 square bracket index. Come outside that square bracket. We're going to say comma. We're going to say and nums2 because it's in out, so we have to use that and sign. Nums2 comma m comma mid. Boom. And once again, this get value 1 is for the negative integers. Then we can do the same thing for the positive integers by saying else we could call get value 2. So we're going to say result plus equals get value 2. Open up the parentheses. We're going to say nums1 square bracket index So y'all come outside of that, and we're gonna say and nums2, comma m, comma mid. Boom, just like that. Sorry, y'all, it should be an S right here. And let me just get rid of this space right there. So it should be an S right here as well. And yeah, that looks about right. Then we need to return true if we found at least K products less than or equal to mid. So for that, we come right here and we say return result greater than equal to K. Remember, this is going to return a Boolean if it's true or false. Boom. And now that's it for the helper functions. Now let's get into this main function all the way up here at the top. Now, for this, first we're just gonna declare variable nums1, and we're gonna set that equal to nums1. Then we're gonna do the same thing for nums2 and set that equal to nums2, and that's just going to allow us to mutate nums1 and nums2. Then we're gonna say let n equal nums1 dot count, and we're gonna say let m equal nums2 dot count, and that's gonna get us the length of nums1 and nums2. Now we need to find the minimum and maximum value from the edges of the sorted array. So we can say let min index equal min, open up the parentheses, nums1 square bracket 0 and nums2 square bracket 0. Remember, these are sorted arrays, so the smallest element or the minimum element will always be at index 0. Then we're going to do the same thing for the largest element. So we're going to say let max index equal max, open up the parentheses. We're going to say, nums1 square bracket n minus 1, say comma, nums2 square bracket m minus 1. Just like that, y'all. Now we need to set the search range for the binary search, the possible min, and the max product values. So for that, we come underneath this and we can say declare a variable called left, and we're going to set that equal to min, open up the parentheses, and that's going to be the min index, comma, max index times min index, and that's going to return whichever one is smaller. Then we need to do the same thing for the right, and this time it's going to be, we're going to find a max value, so we're going to say var right equals max, open up the parentheses, max index times max index, comma, min index times min index. Boom. Now we're going to perform our binary search to find the smallest product for which there are at least k smaller or equal to product or equal products. So once again, we're going to do our binary search. We're going to say while left is less than or equal to right, we're going to open up the brackets. We're going to say let mid equal left plus, open up the parentheses, right minus left. Right minus left, divide that by 2. Boom. Then we're going to say if valid, which is our last helper function that we created, open up the parentheses, and because it's in and out, and nums1, comma, and nums2, comma, n, comma, m, comma, mid, comma K. I'm going to open up the brackets. And we are going to say, we're going to store the potential answer by saying result equals mid. Then we're going to try to find a smaller one by saying right equals mid minus 1. Then we could say else, come right here, and we're going to say left equals mid plus 1, which means not enough products are less than or equal to mid, so we need to search higher. And after we've done all that, we could come right here, and all we have to do, say return results, y'all. That should be all she wrote. I know that was a lot today, but we made it. We got through it. Okay, let's see. We got our first error. Cannot find result in scope. So what did I did something wrong, or I didn't declare result. Sorry, y'all. So this, let me declare result real quick. It should be result. We should set that equal to 0 to start. Now let's give it another run. See what happens. Ooh, and it's accepted, y'all. That's what I'm talking about. Let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see. Ooh, that's what I'm talking about, y'all. 401 milliseconds beats 100% of users. That's what I like to see. So before we go, y'all, let's make sure you get one more look at the code. We'll start with the helper functions. This is the first helper function right here. Boom, get value 1. Read it, learn it, love it. This is the second helper function right here. Boom, read it, learn it, love it. The third helper function is right here. You already know what to do. Read it, learn it, love it. And finally, this is our main function. This is the top part of the main function. This is the bottom part of the main function. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.